All right, guys, so let's finish up. So I actually established where we went wrong with the variance. I'll tell you. So if you look, our formula that we have on our formula sheet, it's not that it's wrong, it's just that it's not the most ideal. Let me be politically correct. So if you look here, this is the same, this is to calculate the same thing. Why isn't it allowing me to? I want to use my pen. Ah. Let me close this. Maybe there's too many things running. Does this when there's a lot going on. Just give it a second. But we can see the formulas. So you can see here, there's no brackets. Okay? And then there's also no indication that here, when we're saying x2, we're referring to each x variable, sorry, each variable within our data set. Remember, x is talking to variable in the data set. So here they've actually put xi, meaning iteration. So basically, every one of them we have to calculate for 6 minus your mean. This is another symbol for mean, your average, to the power 2. Okay, I think you're whispering that. Okay. Then, after calculating the difference between each of those, we then sum it. Okay, and then we divide by, here we had 9 minus 1, which would then give us 8. So, in the interest of saving us time, I just want to show what I'm basically saying. So, can you see there? We had 6, we had 2 6s. There you can see 6 minus our average, which was 12.44 squared. Okay, what did we get? You get 6.44. Then you square that, and then you get 41.4736. You do that for each of them. Okay. After doing that for each of them, you then have to sum all of those squared differences, which is what you do here. Can you see that? So that's all of the things we calculated. Remember 6, we had 2 6s, so we had 2 of the same. Okay. So your total on the numerator should be 334. Okay, 0.2224. Okay. And then here you can see we divide by 8. And then that's getting you to the 41, which they have also in the back of their textbook. Okay. So obviously that will then adjust your standard deviation. It will also adjust your covariance, okay, coefficient of variance. Yes, okay. But those ones are easy as long as you've gotten your variance correct. Okay, so we won't bother with those ones. Okay. So let's continue with the individual, okay? As in these calculations, huh? Okay. You don't want to take a picture? Because then we can't go. Oh, okay. Okay. So this is why it's important for you to practice. And remember, the formula sheet, we need to make it our own. Okay, so as you're practicing, you see that, no, man, this formula that I'm using is not getting me to the same answer. So something must be wrong here, okay? You can quickly go into Google and you can search formula 4 and then go to images. It will populate and provide you with a formula, all right? You can also use, you know, your chat GPTs as well to say, I've got this data set. Calculate for me this, that, and the third. Then it will give you a breakdown of, yeah, ask for as much detail as possible. And so I'm just showing you that you shouldn't be stuck. It's not game over. Oh, your hand is on your cheek. Hi. Next one, what? Next one. Oh, step. Is that fine?
So all of the answers
That followed.
are in the workbook also.
Yeah, they should be at the back, aren't they?
There's no explanation.
Yeah. It's not as detailed. It's not as detailed.
Oh, I found them.
You found them? Oh, so they're there.
Is it the same? Is it the same?
It's the same. You're getting the same 41. But again, it doesn't explain that step number 3. Okay? Hey. Wow. Okay. No, that's fine. So then we go to the IQR. What does the IQR stand for? All right, interquartile range. Okay. So you are taking basically your third quartile and minusing it from your second quartile. Okay. So if we go back to what we had over here, I'm just going to quickly. You minus from the third quartile. Third quartile minus the first quartile. Is it making sense? Okay. So what do I want to do? This is what I want to do.
So would it be the 18.5 minus?
We'll calculate it just now, but I just want us to visually see what we're doing. Okay. Let me get rid of this as well. So here you can see this is your, let me use a different color. If we go down like this is your first quartile. And this is your quartile 3. Right? Quartile 3 is from, it's all of this, isn't it? Quartile 1 is just this portion. Okay? So if we are minusing, what are we then looking at? Quartile 2, yes, and this here. So between here and here. Which is your middle 50%. Okay? All right. So that's all that I wanted to quickly highlight. Okay? So that's why we call it interquartile range. Okay? Because we've got 2 quartiles there as well. So 100% what you said, our quartile 3 was 18.5. All right. And then our first quartile was what? 6.5. And then are we done? We have to say what? Divided by? Divided by 2. Divided by 2. Which gives us what? Which gives us 6. Which gives us 6. And then what does this tell us? The 50% is 6. Okay. So here, I'm going to actually just read it because I don't think my English will capture it as well as they have here. It says, where am I? Over here. The average dispersion around the median is 6 newspapers. Okay. Average dispersion around the median is 6. Okay. Then the last one is then your, what does QD stand for? What did they ask us for here? They asked us finally for determine the, and the quartile deviation. All right, interpret your answer. Okay, so that's your quartile deviation. This one here. Actually, that's what we calculated by dividing by 2. Sorry. So it is the 6. your interquartile is literally just the minusing of those two. Yeah, and the minusing of those two, what did we get? Should give you 12. Can you see? I'm just looking at this here, the numerator side. The minusing of those two will give you 12. Okay, and this will give you 6. And remember, we said I accidentally said that this is the dispersion around the mean. This is the one. Quartile deviation is your dispersion around the mean. Okay. So yes. Now I want us to calculate the mid 70% range. How do we do that? Mid 70% range of our data. Okay. Do you guys remember that we spoke on, when we went through Learning Unit 3, we spoke on this thing called percentiles. And percentiles is very close to quartiles. In fact, it's the same thing for the most part. It's just, remember, quartiles, we're saying we're moving in quarters. Okay? We could say we want to move in halves. We could say, I know there's also moving in fifths. I just don't remember the actual term for it. Okay? So percentiles is now saying, we can say we want the 70th percentile. Okay? That would then mean we're looking from the beginning to wherever we would have. I think 70% would be thereabout. Because remember, this is 75, isn't it? That's 75%. So 70 would be somewhere there. Okay? So we could say we want the 70th percentile, which would then pertain to all of this here. But they basically said the middle 70% range. So how would we then get the middle? And now I'm going to, now I'm going to erase what we have over here. We want the middle 70%. So when we think, we know that this is 100%, isn't right at the end. And this is obviously 0, isn't right at the beginning. How do we get the middle 70%? Or what would be the middle 70%? In other words, how would we have 70% within the middle? What would be on the ends? How are you getting your 15? The gap between 100 and 70 is 30, right? So you have to divide by 2 because we want it in the middle, isn't it? So that we'll have the difference, an equal difference on both sides, isn't it? So let me use a different color. We want 15% over here, and we want 15% over here. Everybody getting that? Which is then going to give us a middle of what? Of 70%. It's now making sense, huh? Okay. So, hey, guys, get a good night's rest, né, when you're going right. Because if you don't sleep, hey, you just see 70% and throw in your answers. This is what we want. We want this data. Okay? So we then go to our formulas. Now, if they just wanted 70%, would be easy. We would just take this percentile formula here. Can you see it? And their px is the value at which x percentage of data lie below that value. So if we just wanted the 70, so here's our 0, here's our 100, and we wanted 70, easy. We would have just applied that formula as is. Oh, am I standing in your way? We would just apply that formula as is. But because they want the middle, we can't do that. So how do we get that middle? we now need to say, okay, how do we get the first 15 and how do we get the last 15? From here to here is what? 15. Okay, so remember our formula. What was our formula? It was px is equals to x n plus 1 divided by, okay, so if we want 15 percentile, we then say p15, okay, is equals to 15, n is what? 9 plus 1 gives you 10 divided by 100. So, okay, but here, yeah, it's fine. It's fine. So our answer here is 1.25. How are you getting? Okay, 1.5. So then we go back, right? 1.5 again. We then say 1, and then we know half, right? But remember we said 6 minus 6 is going to give you 0. Can you see that? So half of 0 is 0, okay? So we're just going to take the 6. So our answer for the 15 percentile is then obviously, final answer here is 6. Cool. And then again here, yes? Yes, no problem. So we said 1, right? Our answer was 1.5. We're looking for position 1.5, isn't? So we have 1, right? Then to get the half, we say, okay, what's the next number minus the first number that we've gotten? Okay, because we want a number in between these two, isn't? So then we say, because remember the last time we had what? 7.5. We then said 19 minus 18, which gave us 1. And then we said times 0.5, which gave us 0.5. And then so we took this 18 and we said plus half, which then gave us our answer of 18.5, okay, which is this. Okay, so we're doing the same thing, but now because we're saying 6 minus 6, we get 0. So there is no half to add on to the initial 6, so we just say 6. Okay, so we've got our first amount there, we've got our 6. Now, how are we going to get this one? That 15 over there, or should we say the percentile that will give us up until this 15? What would be the difference between 100 and that? It would be 85, okay? So the percentile we're looking for, do it in blue, px, no, I don't need to do the formula again. Let's just do 85. Okay, now I'm going to quickly show you guys something. If you want to make your life, what I think would be making your life easier, you can also just say p 0.85. Okay, and because I've said 0.85, I've basically just removed the 100. So it would then be is equals to 0.85 times, we know n is equals to 9 plus 1, which is 10, which would then give us, is it 8.5? Okay, should then give us 8.5. Okay, So I don't know, for me, I think that's easier, but you can do what we did initially, you'll get to the same answer. So we got 8.5. We know we have 9 variables. So that means that 8 is over here. And then we're saying we need to get that half. The next number is 24. So we say 24 minus 19 gives you what? Gives you 5. 5 times half, isn't? Times 0.5 gives you 2.5. So we're saying 19 plus 2.5. Am I moving too fast? Are you with us? Remember, 8 gave us the 19, so we're happy with that. But then we have a half that we need to account for. And that's why we're doing this. It's 24, which was the next number, minus the number we fell on with the 8, gives us 5. Half of that, we get 2.5. So we now want to add the 2. I saw your hand. I'm just going to add and then we'll discuss. Yeah? What do we get? Yes, ma'am.
So if the weights are 0.85, there's no need to
Divide by 100. Yes, that's exactly what I'm saying. Which is why I find it easier. Does it make sense?
Please go back to the other one.
Which?
The one that you did before you started.
Okay. Okay. So our answer here, we said is 21.5. Am I right? 21.5. Okay. No problem. No problem. Okay. And then remember, we are looking for this 70, isn't it? So we're not completely done, isn't it? We need to then get the difference between these. We need to subtract the 85 from the 15 to get the middle 70%. When we subtract 21 from 21 and a half from 6, what do we get? Okay. So now that's our final answer. Okay. You want me to explain? P, the first one. Okay. Right. Which is what you wanted me to explain, huh? I just wanted to make sure we're okay. So remember, we're looking for the middle 70, right? We're looking for the middle 70, which is a problem for us because the middle 70 means it must be central. It can't be from 0 going to 70, or let's say after 30 going to 100. Does that make sense? It must be the middle 70%. Okay? So we don't have a formula that will allow us to just calculate the 70 just like that, and we then get our position, and then we say, okay, the middle 70 should be below these values, okay, or this value, sorry. So we then need to say, that means we need to get our 15%, right? Right? Because we're saying, the middle 70 would then be 100 minus 70, okay, divided by 2, all right? 100 minus 70, you get 30, all right? We want it to be in the middle, so that means that our right extreme, right, should be equal to our left extreme. Does that make sense? So we say, okay, that means 15% this side, 15%, we then have our middle 70. Now the next question is, but how do we get this last 15%? And how do we get the beginning 15%? The beginning 15% is easy because it's from 0 to 15. Does that make sense? We're looking for our first 15%. So we calculate the percentile for 15% to get the first one. And that's what we did. So here you can see we said, yes, which gave us 1.5. 1.5 gave us the position. Yeah? Because remember, we come back here, we look at our ordered data or our sorted data, and we say, okay, this has now become quite a mess. And we say, let me use a different color. We say number 1 in our data is 6. But then we have a 0.5. So we need to also account for that 0.5. How do we account for that 0.5? We have to say the next value minus our initial value, which we've selected. Okay, so we're saying 6, which is the next value, minus 6, which is the value that we've selected, right? With the 1, okay, in this instance, gives us 0. So since we have 0, okay, we can still say times 0.5, which gives us 0. So we have nothing to add to the initial value that we've selected, which is 6. Because remember, we say 6 plus what we have calculated will then give us the value that we want for 0.5. Everybody happy with that first one? Okay, let's just take a breather first before we go to the next one. Okay, we ready? Can we go on? We're still taking a breather. Wow, guys. Okay. Are you going to visit us again?
So the reason why we use 6 is because we can't use those 0.
The initial 6, though, was selected by the 1. That was positioning. Okay. If we had only gotten a 1 and not 1.5, we would have just taken the 6. Yes, now we're still using the 6 regardless because 6 minus 6 is 0. Okay. Remember again, when we had the 8.5 on the previous question, 8.5, we got the 19. After we got the 19, we then said, but we have a 0.5. So we took 24, which is what we did here. 24 minus your 19, which was our initial. Can you see it doesn't mean that the initial is going to be just 1 digit or, it's going to be something small in terms of the difference. Okay. 24 minus the 19, we got 5. And then we said times 5. And that gave us 2.5. Can you see that? I thought we were going to get through the next exercise, but right now I'm not so sure. Maybe. Okay. I'm realizing I'm actually explaining the P885. Can I just go there? Okay. So the P85, remember we said this is then 85% to get to this 15%. And 85% is from 0 all the way to there. But we don't want this initial. Does it make sense? So we're then saying our P15, we need to deduct it from P85. And therefore, we're then getting our P70, but the middle one, making sense, which is what we want. That's what we want, isn't it? Okay, so let's calculate that. We have to calculate that. We then said, okay, we know our formula. We've got it over here. So we then say, again, you can say P85 is equals to 85 times 9 plus 1 divided by 100. Okay, and that's 10, so that's going to give you 850. 850 on your numerator divided by 100 is going to give you 8.5. Okay, so I'm just showing you that either way that you do it, you're going to get to the right answer. So pick whatever is most ideal for you. Okay. Remember, what we've just calculated only helps us select our position in the data set. All right? So we go back and we see our data set. And I'm going to erase everything around here because it's quite messy. I'm sure we might confuse ourselves with everything going on over there. Okay. So what is the position in our data set? Let's see. We said 8.5, isn't it? All right. So again, we are saying 1, 2, 3, 4, 5, 6, 7, 8. But we don't have 8. We have 8 point. If we had 8, we would just say 19. And we'd be happy. Okay? And we'd be happy. But we have 8.5. So we now need to get 0.5 of the difference between the next variable and our initial selected variable. So we then say, what is the difference? The difference would have to be 24 minus 19, which is 5. And then we don't want the whole thing. We want 0.5, so 0.5, which then gives us 2.5. So then we say, okay, 19 plus 2.5, which then gives us 21.5. Is it making sense? Okay. So we now have that, but we're not done. Remember, we initially said here, we need to get the difference between these two to get our middle 70%. And that's what we've done. This was P85, and this was P15. And there we go. So what is it telling us? Again, let us get the nice polished English. It says, it therefore follows that the middle 70% range is 15.50. Okay? So that's the range. The middle 70% range. Okay. Remember, range is what? The difference between your? Okay. Right. So let's see what our time is. I don't think it would be very productive to go any further, but let's just finish this last one. So at least we can say we finished activity 1. So the last one here, they say, what is the minimum number of newspapers a province must publish to fall within 15% of provinces that publish the most newspapers? To fall within 15% that publish the most. So again, it would be good to go to our diagram. And again, now our diagram is looking quite messy. Maybe let's just do another one. So here we have 0 to 100. Okay? What do we want? The top, right? We want the top 15, not just 15, isn't it? So would that lie there, or would it lie here? At the end, isn't it? So it would lie here. We want the top 15%. Okay? Okay? So to fall within that, what must we not be a part of? The bottom what? What is this? This is the bottom what? 85%. So now what must we calculate for? So you're saying we should do P15. But P15, is that not going to give us the...
Yeah, the bottom.
Uh-huh. So what should we be calculating?
85.
The 85.
So would it be the same thing as the one before?
It will be. It will be. Which gave us...
21.5.
Mm-hmm. So here we go. 85. Okay. Which gave us 21.5. So what are we saying? In order to be part of the top 15% or sell the most papers, be within that top 15%, all right, that sell the most, how many papers should we sell? Because remember, what does this tell us? It tells us that 85% of our data, right, is below what? Is below?
1.8.
Uh-huh. So, yes.
The amount of newspapers sold.
Because remember, we got the position already. When we did the calculation, let me say it like this. When we did this calculation, let me actually go to the calculation. Ish, man. This thing is disrespecting me. Can you see this was the positioning? 8.5 was the positioning. So we went back to our data and we said 8.5, what does it give us? 19, we've got the 19. And then remember we said this is, the 0.5 is between, we had to do our calculation to find 0.5 of the difference between the next value and it gave us 2.5. And that's how we arrived at this is our final answer for P85, isn't it? So that's how we're getting the 21. So we're saying this 21, 85% of our data is below 21.5. Newspapers, 100%. Newspapers, okay? So to be a part of the top 15%, how many newspapers should we sell?
21.5.
And more. 21.5 and more. Because we're saying 85 is below, is less than. Sorry, that is greater than, sorry. Hey, it's been a long day, ne? Is less than. Is below, isn't? So that means that this 85, sorry, the top 15% is either equal to or greater than. Greater than. Yeah. Okay, I think I shouldn't do that because I'll create confusion. Right? But greater than, more than. Okay. I hope that equal to or more than. Okay. In mathematics, actually, it would be like so. If we want to go there. Isn't? Okay. Happiness. Just say yes. Okay. All right, guys. So I think that's it for today. But please go and do 3 points. Exercise 3. All right, and 5. Activity. Just activity. Okay. Just activity. Activity 3 in unit 3. Activity 3 in unit 3. And then activity 5 as well. For tomorrow. We're having such a good time. Why would you ask such a thing? For the week.